video, I want to have a look at the sign of a function. So when we're talking about the sign of a function, we're saying for which x values is the function positive and which x values is it negative. So there's two main options we have to solve a problem like this. One of them is to read off a graph where it's above the x-axis and where it's below. But the problem with that is if the graph isn't given to us, it's not always easy or clear how to draw that function. Our other option is a table of signs. So we're going to build up a table based around the zeros or any discontinuities of that function, and then test either side of those points to see whether the function is positive or negative. So let's have a look at one problem, but using both methods. What we're looking at asks us to solve 5 over x plus 4 is less than or equal to x. So first we're going to have a look at solving this by sketching this function. The first thing we're going to do is multiply everything by the denominator squared. Now remember, we do that because we don't know whether this denominator is positive or negative, and if it was negative, if we multiplied by it, we would change the direction of this sign. A squared is always positive, so we're multiplying both sides of the equation by x plus 4 squared. So we're going to end up with 5 outside of x plus 4 because one of them would cancel with the denominator, and that's going to be less than or equal to x outside of x plus 4 all squared. We're going to move everything over to one side of the equal sign. So we're going to have 5 outside of x plus 4 minus x outside of x plus 4 squared is less than or equal to 0. Now I can factorize this by pulling out a common factor of x plus 4, which would leave me with 5 minus x outside of x plus 4, which is less than or equal to 0 still. If I go through and simplify this bracket, I've still got my x plus 4 out the front. Then I'm going to have 5 minus x squared minus 4x. Less than or equal to 0. If I rearrange this a little bit, I'm actually going to pull a negative out of this bracket. So I'd end up with x squared plus 4x minus 5. Is less than or equal to 0, and now I want to factorize this quadratic. So getting my two brackets set up, I'm going to need a 5 and a 1. One of them is going to have to be negative to give us a minus 5 when we multiply, so we'd end up with a minus 1 and a positive 5 to give us that plus 4 as well. All right, now we've got it in factorized form, we can go through and sketch. So we know that we're going to have single roots at minus 4, positive 1 and negative 5. So again, when you draw these sketches, you should be using a ruler, but I can't on this thing. All right, so we've got our axes. We're going to have roots at minus 5, minus 4, and positive 1. So we know it cuts through those points, but we need to know which direction it's going. So if we think about this expanded, this would be a degree 3 polynomial. And we've got a negative out the front. So degree 3 always starts in one corner and goes down in the other corner. Because it's negative, it's going to start up towards the left, end down towards the right, and we don't know what it's doing in the middle, but we know that it cuts through these 3 points. So what it's going to look like is it's going to come down this way, cut back up through 4, and then cut down through that 1 there. All right, so then using our sketch, we can just have a look and see where that function that we just sketched is less than or equal to 0. So we want one that's below the axis. So that's these points in here and these ones here. One other very, very important part of this question that we probably should have done at the start is to have a look at this denominator. Now, because it is a denominator in a fraction, that x can never be equal to negative 4, because that would mean that we were dividing by 0. Okay, so now if we have a look at this function, to get our final answer, we need our x values to either be between, so minus 5 and minus 4. So we'd have minus 5, is less than or equal to x. Normally we will put less than or equal to minus 4 here because of this less than or equal sign, but we know that x cannot be equal to minus 4, so it just becomes a less than. Or we can have x is greater than or equal to 1. All right, so that's one method to get that solution. I'm going to have a look at the same problem, but using this method using a table of signs. So the first thing we probably should have done last time as well is recognize that x can never be equal to -4. Write that somewhere nice and big and obvious so you don't forget it at the end of the question. All right, now we're going to start by moving everything over to one side of that inequality sign. So we're going to have x plus 4, 5 over x plus 4 minus x is less than or equal to 0. We're going to make these have a common denominator to become one fraction. So we'd have 5 minus x outside of x plus 4 all over x plus 4. It's less than or equal to 0. We can expand that out. Than or equal to 0. I'm going to pull out my negative and factorize this. I already did this step in the last example, so let's just skip to the factorized version, which would have an x plus 5, x minus 1, still all over x plus 4, and that's going to be less than or equal to 0. So if we have a look at this, we know that we're going to have zeros of this function at -5 and 1. And we know we're going to have a discontinuity at x equals -4. So those are the values that we're going to build our table around. So we're going to have x, and we're going to have the left-hand side of the equation, the sign of that. So we'll leave a space. Our lowest value there is -5. Leave another gap. Then we've got -4. Leave another gap. And then we've got 1. And we need one more value up here. At 5 and at 1, the value of that function on the left-hand side is going to be 0. And at 4, it's a discontinuity, so that doesn't exist. But now we need to pick values in here. It doesn't actually matter which values you pick it to go in here, as long as they are fitting in between the values we're already given. So let's pick -6, -4.5, 0 and 2. And then we're going to substitute those values into the left-hand side of this equation. We don't actually mind what number we get as our answer, we just care whether it's positive or negative. So if you go through and do that, we'll end up with positive for -6, negative here, positive, and then negative. So if we're looking to find when that function is less than or equal to 0, we're looking at when it's negative. So for us, it's going to be between that -5 and the 4, where it's negative in here. And then it's also going to be above that, that 1 there. So our final answer then is going to be that -5 is less than or equal to x, less than but not equal to, because of this, 4, or x is greater than or equal to 1, just like we got in our first example where we sketched it. So there are two different methods for solving the same problem.